for joining our webinar this morning. We're going to have an informational webinar on the NASA Applied Science Project. My name is Christina Supples. You've all received lots of emails from me about this project, and we're really excited that you could join to learn more. The attendees we have on this call are representing...
Hello, Jessica.
We have folks from Brazil, Colombia, the DRC, Ecuador, Indonesia, Peru, and Vietnam. Because we have folks with many different language capacities, we are also going to offer simultaneous Spanish translation. And for anyone who is not already linked in with Rodolfo, I'm going to turn it over to Diego. Diego, could you just briefly explain in Spanish how someone would access that translation?
Definitely. Bienvenidos todos a esta sesión bilingüe sobre el proyecto que vamos a desarrollar. Las personas que necesiten traducción simultánea al español deben enviarnos su ID de Skype a Rodolfo Scanone o a mi persona y vamos a tener una conversación separada en Skype a través de ese servicio. Entonces, quienes deseen en este momento tener una conversación simultánea en español, les pido que por favor me envíen a mi correo diego.ochoa@undp.org su usuario de Skype y nosotros conectaremos la llamada a través de ese formato.
Thank you, Diego. So moving forward, we have a very interesting agenda today. I'm sorry, everyone can probably hear my daughter just woke up. I work from home. Dr. Jamison Irvin will start the call. She's the manager of UNDP's Nature for Development program, and she's going to provide an overview of how this project fits in with UNDP's larger conservation sustainable development initiatives. With that, Jamie, I'll turn it over to you.
Thank you very much, Chrissy. Rodolfo, are you translating simultaneously, or shall I just begin?
Jamie, you should begin. He's going to be translating on Skype, so it won't interrupt your broadcast at all. If you could just try to speak slowly.
Jamie, how are you? I'm already
Great.
translating, and we have some, Jessica is here in the translation in Spanish, so you can proceed. I'll be translating for you.
Terrific. I'll speak slowly to allow for translation. So, good morning, everyone. My name is Jamison Irvin, as Chrissy said, and I manage the Nature for Development program at UNDP. I want to give a little bit of background to this project of supporting 6 national reports with spatial data. Let me start by describing a situation that our team faced over the past 3 years as we supported 45 countries in developing their national biodiversity strategies and action plans and their 5th national reports. We reviewed about 35 of these national NBSAPs, as well as the 5th national reports, and we came to some conclusions. And we concluded that very few of them had spatial data. We conducted a study, and in the hot link we'll send you the full study after this webinar of all of the maps used within the post-2010 NBSAPs and all of the 5th national reports. We went through every single one, we documented every single map, and we categorized them. And here's what we found. We found on average that the number of maps per NBSAP per country was about 4. And the average number of maps in the 5th national report per country was about 5. 32 of the NBSAPs, we reviewed 110 of these, 32 of them, or almost 30%, and 20 5th national reports had no maps at all, and 78 NBSAPs, or 72%, and 90 of the 5th national reports, or 62%, had 4 or fewer maps. 87 countries, or 83%, had a combined average of only 7 maps or fewer between both reports, and 73 countries had a combined average of 4 maps or fewer between both reports. We also looked at the kinds of maps that were available. We looked at what we called non-actionable data layers. This is just a basic variable or feature or a map of the country. We looked at potentially actionable data layers, such as corridors, habitat maps, invasive species maps, protected area maps, and we were looking for maps that were actionable. These were maps that would tell policymakers what to do next. For example, climate change vulnerability, or future human footprint, or proposed new protected areas and protected areas in biodiversity. When we analyzed all of the data, we found that 1/3 of all national reports and 1/5 of all NBSAPs had either no maps or only non-actionable maps. 80% of the national reports and 70% of the NBSAPs had no actionable maps whatsoever. They only presented maps of what is rather than what policymakers needed to do. Only 1% of the maps included socioeconomic data, and fewer than 4% of all maps focused on ecosystem services, such as provision of water or provision of livelihoods or disaster risk reduction. One of the things we know is that the Aichi targets have been fully embedded into the Sustainable Development Goals. And we know that post-2020, there will be a realignment of the Aichi biodiversity targets with the Sustainable Development Goals. There will be some new set of targets from 2020 to 2030, and these will be fully aligned with the SDGs. We also know that nature has an incredible contribution to achieving the Sustainable Development Goals, including reducing poverty, alleviating hunger, providing clean water, etc. But this fact was not reflected in the NBSAPs or in the national reports. Our team believes that there are at least 10 key questions that are missing from the national reports that we believe need to be strengthened. The first one is, where can we manage biodiversity to reduce poverty? This relates to Aichi Biodiversity 2 or SDG 1. For example, where should a forest that is turned into a protected area, where can it most alleviate poverty and provide livelihoods? Second, where have we surpassed safe ecological limits related to Aichi Biodiversity Target 4 and SDG 6, 14, and 15? Where on the landscape and seascape has that occurred? The third are, where are the opportunities to at least have habitat loss, particularly for forest? This is Target 5 or SDG 15. Number 4 is, where on the landscape must we implement sustainable agriculture, forestry, and aquaculture? Where do these places need to be located to protect biodiversity and sustain ecosystem services? Number 5, where is pollution having the most harm on biodiversity and on human health? Number 6, where do we need the most effort on invasive alien species? And that means early detection, prevention, control, and eradication. Number 7, where are the most vulnerable and intact reefs and ecosystems? And where do these need to be restored and protected? Related to Aichi Target 10 and SDG 14. Number 8, where should new protected areas go? We know that we have a target of 17% terrestrial, 10% marine, but we know that these need to be distributed in such a way that they maintain ecosystem functions and services, and that they provide for a truly representative and well-connected protected area system. Number 9, where must we restore, protect, and sustainably manage ecosystems in order to avoid extinctions? And finally, perhaps the biggest one in its relationship to the Sustainable Development Goals, where must we restore ecosystems in order to maintain essential services? The current data within NBSAPs and the 5th national reports that we reviewed really don't allow for this kind of data for planning, for implementation, or reporting on those 10 key questions. The missing data include population, poverty, land rights, socioeconomic data, natural resource productivity, land cover change, and in particular forest cover change, invasive alien species, climate vulnerability, the human footprint and the projected future footprint, sustainable land management, pollution, and the location of essential ecosystem services. And most importantly, I think, is water and disaster risk reduction. Those are the two that really stood out that were almost completely lacking. In response, our team worked about 18 months ago, 2 years ago, with the Pulse Lab in Kampala and the government of Zimbabwe to develop a beta test. And we'll send you the link, it's in the reports. This beta test integrated some 25 features that helped planners understand what are the global data sets that could be used to help them plan better. Essentially, they did not have any data sets, and we said, yes, there are global data sets that you could use to help planning, to inform your NBSAP and your fifth national report. As part of this project, we are now planning to expand this tool globally to make it available to anyone who's interested. UNDP and the UN Pulse Lab, with our partners, developed this beta version with biodiversity significance, protected area footprint, threats to biodiversity resilience, and mainstreaming. And now we want to scale it up to all countries. This is part of our support for 65 countries through our 6 National Report project, of which everyone on the phone call is a part of, with the financial support of the Global Environmental Facility. And this is contributing to CBD's requirements for 6th national reporting. In that project, we're preparing technical support, consultation support, administrative support. We also would like to offer to those countries who are interested data support. We're creating this sandbox data environment, which means that anyone can bring their data to the sandbox, everyone can play in the sandbox, and we want to provide tools to make the most use of that environment. We will provide a minimum data set of approximately 50 layers that are available globally right now to answer some of these essential questions. We also want to allow countries to upload their own national data sets and keep this in a proprietary environment for their own accounts if they so choose. We want countries to be able to query the data together. So, for example, overlaying key biodiversity areas with protection to say where should the next protected areas go, to answer at least some of those 10 key questions. And importantly, we want to allow users to draw shape files to capture local knowledge, for example, in workshops, to know where is poaching occurring or where are invasive species occurring, which you may not have solid data sets, but you do have local knowledge. Finally, I just want to briefly introduce the NASA project. A year ago, the team that you'll be hearing from submitted a proposal to NASA that was successfully funded that tries to integrate many of these data sets around forest-related data. I'll just briefly touch on what the project entails. We will update the human footprint to 2015. We will project wilderness decline by 2030. We will map forest condition and forest cover loss. We'll identify the rates and the drivers of loss of intact forest landscapes. We'll map forest fragmentation and forest connectivity. We have a range of partners, many of whom are on the call today, and we're also in discussion with some new partners that we believe could bring some of the missing data sets to the table. But most importantly, will be you, the countries, to bring your data sets to help enrich the data environment. Finally, we proposed a list of countries we thought would be leaders in this area: Brazil, Colombia, DR Congo, Ecuador, Guatemala, Indonesia, Peru, and Vietnam. With that, I turn it back over to Chrissy.
Thank you, Jamie, for that wonderful background on UNDP's conservation and sustainable development initiatives and how this project fits into it. For everyone on the line, I'm going to suggest that we save questions to the end. We've allocated at least 25 minutes for that, and can certainly stay on the line longer if needed. So we'll keep going, and I'm going to turn it over to the science and data team to give a little more project background, describe the data layers that are going to be developed during that project. So first, we'll hear from Dr. Andy Hansen at Montana State University. Then we'll hear from Dr. Scott Goetz at Northern Arizona University. Then we'll hear from Dr. Oscar Vetter at University of British Columbia. And last, we'll hear from Dr. Patrick Jantz at Northern Arizona University. And so with that, we're going to turn it over to Dr. Hansen. And Diego.
Hello, everybody.
Great. Okay, looks like the presentation's coming up. Over to you, Dr. Hansen.
Yes, thanks, Christine. And thanks, Jamie, for a wonderful introduction. It's really wonderful to have this webinar and to be able to introduce the project to you in the various countries that are participating. We'll give just a fairly brief overview of this portion of the bigger project that Jamie described. And I think we'll see if I have control of the slides. Christine, it looks like not. How shall we advance the slides?
I believe that you do have control. Diego, could you help out with that?
I have the presentation, so I would like to ask Dr. Andy to just let me know when he wants to have the next slide.
Yeah, why don't we go to the third slide? Thanks.
Potential
the third slide. While he's doing that, I'll just give a little background that you might wonder why a space administration would be interested in conservation. Well, an important component of NASA, the National Air and Space Administration in the United States, focuses on Earth sciences, trying to understand the Earth, largely from use of information gained by satellites. And this project is actually aimed at trying to fill some of the data needs that Jamie described by using satellite data. So are we able to advance to the third slide?
Diego, is it possible for you to change the slides?
No, it seems like it's not working, the presentation. So sorry. Let me check out what is going on, because now I am showing the 5th, so not sure what's going on. Let me check out again. So sorry for the technical glitch.
It's okay. We just saw it progress, actually.
Is it moving?
Yes, we got it.
Okay.
And if you could put it in full view mode, please.
And then for all the presenters, this is just a reminder to speak slowly, myself included, because we are doing simultaneous translation at the same time.
Okay, very good. Thanks, Diego. Andy again. Of course, the Convention on Biodiversity, among its many targets, included those relating to fragmentation and connectivity and the strategic action plans. And if we go to the next slide, the goal of our project is to try to provide data and analyses to support the biodiversity plans with regard to fragmentation and connectivity. a challenge to doing that is to have so we continue to have a few difficulties in changing slides.
Diego, maybe you can send me the presentation and I can upload it for you.
Yeah, I can change the presenter right now. So,
And if you can send me the presentation, I can do it for you. We apologize for this technical difficulty. Please bear with us.
yes, I so sorry because of this. I don't understand what is going on. Are you seeing the third slide now?
We don't see any slide. Can you please send me the
Yes.
presentation?
Okay, while I am sending you, I'm going to change to presenters. Hold on.
Rodolfo, if you have the presentation, could you send it to me?
I am sending your way.
Via Skype?
No, it's kind of big, so I am just sending through Skype through.
Thanks everyone for your patience. Technology's incredible at bringing us all together. It's also our weakest link.
Maybe we can take this time for some questions, Chrissy.
I was just thinking of that. So everyone in the call is on mute, but there's a raise your hand function and you can also type your questions in. So while we're waiting to get the presentation up and running, this is a great time for us to take questions. If you prefer your question in Spanish, feel free to type it in Spanish and Diego can translate for us into English.
Okay, so sorry.
Okay.
I am just putting the microphone for people who wants to raise the hand. I'm going to open the microphone for Gabriel Jaramillo.
Hello, everyone. Greetings from Ecuador. Can you hear me?
Yes.
Great. I'm just wondering, yesterday we received a message informing that we are going to start the sixth report to the CDB. So I'm sure that this project and that project are going to be completely integrated. Is that correct? Simple question.
Do you want to take that, Jamie, or me too?
Chrissy, would you like to take that?
Yeah, sure. That sounds great. So my name is Chrissy Supples, and I've been corresponding with all of you, and I'm excited that you got my emails last night. For those on the other side of the world, you'll be getting your notifications today. So we are hoping that these two projects will sync perfectly with each other and that the 6NR project would be the mechanism for delivery of this project as well. As I've discussed with everyone on the call over email, this is not a grant of money, additional money for the 6NR, but it's a grant of data and knowledge and technical capacity building support. So each of the countries we invited to attend, you have high force resources in your country, and your NBSAPs and your national reporting will be significantly tied to forests in many ways. And so we hope that access to the data that we're about to learn about, which are cutting edge and are being developed just through this project, specifically to improve national biodiversity planning and reporting, could be a tremendous asset to your work. Did I answer the question?
Yes. Thank you very much.
Other questions?
Yeah, there's another question that's been written in. Jamie, this is a great one for you. Could you please elaborate on those potential project partners you are contacting, hoping to fill in some data gaps?
Sure. Yes. Right now we are working with the universities on the partners, as well as the UN Pulse Lab, as well as NASA. NASA has a number of other data sets that we're interested in, and we're looking beyond the earth sciences component, but we're also looking at the Nature Conservancy, Conservation International, as well as National Geographic, who have many other data sets, and we're exploring some global data sets, some national data sets. We essentially are trying to create a sandbox environment to which anyone who has relevant data can bring their data and also have open access to those data sets that are not restricted. We understand that some data might be sensitive, and therefore we also will create a feature that countries can have an access to their own site that's not public.
¿Estás despierto? Grandioso.
Great. Does that answer the question?
I'm sorry.
Okay. It looks like we have Gabriel's raised his hand again. Let's see. Hi. Did you have another question, Gabriel?
Not really. That was a mistake. Please go ahead.
Okay. Looks like we have another question. How will already existing national and subnational platforms be integrated into the NASA project platform? A great question.
A really good question. We leave that up to the countries. We're creating the minimum. If countries have better systems, better data, we certainly don't want to duplicate any of that. We would leave that up to you. But maybe, Chrissy, I don't know if you also have a perspective.
Oh, that's a really good question. And we'll do some timeline slides after the presentation of the data package. And I think that would be a good time to talk about it. But we really want this project to work for each country that signs on to it. And so we don't want to tell you, this is how it will look. We want to hear what your data needs are. And I know that the data scientists are very interested in that as well. So we're interested in it from a national planning and reporting purpose. And the data scientists want to make sure that the data they're developing are actually being used by practitioners around the world to make a difference in conservation. So that's something we'd want to work very closely with you on, so that the end product was something you could use.
And at a minimum, you would simply get the data and use it and integrate it into your existing platforms.
Great.
I see that I now have the screen and I have the presentation loaded. Shall I continue, Andy?
Yes. Shall we go to, shall we pick up on slide 4?
Is this slide 4?
No, that's number 1.
Okay. This one, Project Flow?
1 before that, 2 before that.
Okay, Project Purpose.
Okay, so we'll begin here. Thanks for everybody for staying with us. So fundamentally, as I said, the purpose of this project is to try to use some of the global data sets that have been developed through NASA and other satellite derived data to help inform information about connectivity of forests in terms of the strategic action plans. And if we go to the next slide, it's the flow diagram that, sorry, the team. Yeah, that's what we want.
The team or the flow diagram?
I'd like the flow chart. There we go. So basically, we're drawing on various types of satellite data Landsat and MODIS in particular, if you're familiar with that. We're now looking at the top of the slide. And we'll be shooting to use those to map at a 30-meter resolution forest condition. That's 3 elements of forest structure that we'll talk about. And then human pressure in terms of an index called the human footprint. And our goal is to do something somewhat innovative in forest ecology, and that's try to integrate those measures of forest condition with the human footprint to identify forests that have the structural complexity that's important for biodiversity, and also low human pressure. Those are probably areas particularly important for biodiversity and perhaps for conservation planning. And we would then assess connectivity of those forests of high integrity through the project. Now, as a way to validate this forest integrity measure, we'll be looking at to what extent they relate to changes in the occurrences of forest mammals that are known to be at risk. And then for both the forest integrity and for the mammal species, we'll be trying to basically assess trends in those through a systematic approach, as indicated in this color bar at the bottom, where we try to identify if a resource is likely deteriorating on the left side to stable in the middle to likely improving, as a guide to which of the metrics may be the most concern for management. And as Jamie said, our intent is to try to prototype this overall approach in 8 countries and then implement them in an additional 24 countries. And that all this would be done in the context of that UN Pulse decision support system that Jamie described earlier, the common use area that she described, as well as trying to make the products available through some other data portals. And that there would be a variety of trainings that were associated with the project to help people be able to actually use the data. That's an overview of the pieces of the project. If we now show the team, I think that's the next slide.
Yes, is it showing?
Oh, no, there we go, yeah. So some of these folks will be coming on board, of course. Jamie's team is listed under UNDP down the slide. In terms of the universities, we have my team at Montana State University, and then a team from Northern Arizona University. Both Scott Getz and Patrick Jantz will be speaking today. They're focused on assessing connectivity. And then Oscar Venter from Northern British Columbia will be representing the human footprint data layer. He and James Watson from University of Queensland have developed that. And the forest condition layers were developed by Matt Hansen at the University of Maryland. He's in the field somewhere around the world right now and is not able to join us. And then, of course, as I said, we'll be working with Paula at the UN Pulse Lab Kampala, and then also Cindy Schmidt is a key liaison with the NASA Applied Sciences program. And that takes us then to to the countries that that we'd be piloting in. We've already begun to develop pilot data for Colombia and hope to be sharing some of that with those of you from Colombia next month in association with the International Conservation Congress. And if we go to the next slide,
Forest condition?
yes. So Scott, this would be where perhaps you might take over.
Okay, hopefully everyone can hear me all right.
Yes.
Good. So this is really data sets that provide the basis for much of the forest condition characterization. And much of this is Matt Hansen's work. And I've worked with Matt on this. I expect many of you are familiar with some of these data sets. But what made possible this very large area mapping of forest change and time since disturbance is the opening of the Landsat archive combined with very high performance computing capabilities. So that made it possible to use literally hundreds of thousands of Landsat images to map at 30-meter spatial resolution for the entire time period of Landsat data, which is mostly based on thematic mapper data back to the early 1980s. So using those data, we're able to, again, map canopy cover density, and then look at forest losses as well as gains over that entire time period based on percent changes in canopy cover. And using those same data, note when disturbance occurred. So those are two key variables that will go into the steps that follow, which I think Andy and maybe Patrick will talk a bit more about. Another component of what we're able to do recently is estimate canopy height. So that's based on a combination of Landsat data as well as a satellite LiDAR system, laser altimetry system that provides measurements of canopy height, and then couple those with the Landsat reflectance data to estimate height, and have a couple papers on that now showing that it is possible to do with Landsat data. So I think maybe we can reserve any additional comments on that or to questions. Over to Oscar, I guess, now.
Okay, hello everybody. So the map that you're seeing on the top of this slide is showing the global human footprint for the year 2009. And this is a data set that we published and released last year. So the human footprint combines 8 data layers, which each represent a major form of human pressure on forests and their biodiversity and ecosystem services. Now, the second figure on the bottom lists the individual data sets that make up the human footprint. So these data sets include maps of built environments, population density, electric infrastructure, croplands, pasture lands, railways, major roadways, and navigable waterways. So to create the human footprint map, each pressure is assigned a weight. before they're summed together to create the map of cumulative pressures. So for this project, we're updating the human footprint map to the years 2000 and approximately 2015 to better coincide with the time period considered in the project. Then we'll be using these new data sets to complement the direct measures of forest condition. The human footprint gives us information about the pressures in and around forests that can otherwise be missed, and therefore allow us to better identify forests of the highest integrity. And we can move on to the next slide. That's all I have for this.
Okay, thanks, Oscar. Andy again. Again, this just illustrates our intention of combining those measures of forest condition with the human footprint in order to identify these forests of high integrity. And again, these would be taller, older forests with high canopy cover and lower human pressure. If we go to the next slide, this is some detail on how we would derive forest integrity. So there we go. And just in brief, we have this table depicts 9 classes of forest condition, with those that are relatively recently disturbed, less than 8 years, versus 8 to 17 years, versus those that have not been disturbed since the beginning of the Landsat record in 2000. And then we'd have 3 classes of forest height, and we're suggesting these represent different seral stages of forests and different structural conditions that have differential values for plant and animal species. We would then have 3 classes of the human pressure from the human footprint, and basically then develop this index of forest integrity that that has a weighting for the forest condition and a weighting for human footprint. And that would end up with a map from 0 to 10 of this forest integrity index. And the next slide would be to Patrick to talk about using that data set.
Hi, can you all hear me?
Yes.
Great. Okay, thank you very much, Andy, for that. So just taking a look at the flow chart on the upper left portion of this slide, we've already covered how we plan to derive wall-to-wall maps of forest integrity. And so one of the additional steps that we'll need to do is to derive a set of high integrity forest patches. And so that will be one of our first tasks. And then once we do that, the next step will be to map optimal corridors between forest patches. And so these corridors are areas that we expect to be most important for maintaining connectivity between nearby high integrity forest patches. And so these corridors will take into account the heterogeneity of the intervening landscape, and they can be made narrower or wider depending on local opportunities or barriers to conservation and management. We also plan to include information on the location of protected areas to better understand how they contribute to connectivity of high integrity forests. So by the end of this step, we'll have a set of high integrity forest patches, a set of protected areas, and then the corridors mapped between them. And so then from this set of data layers, we'll conduct 2 primary analyses. One focuses on fragmentation and one on connectivity. And those are complementary analyses, with the connectivity analysis being somewhat more sophisticated. So For the fragmentation analysis, we'll use landscape pattern indices to describe the spatial context of high integrity forest patches. So landscape pattern indices describe important quantities like the amount of interior forest and the amount of forest edge in a given landscape. And these are good indicators of the impact of deforestation on forest ecosystems. And then for the connectivity analysis, we'll use a graph theoretic approach to analyze this network of high integrity forest patches, protected areas, and corridors to identify priority areas that are most important for maintaining connectivity in the landscape. So graph theory models the relationships between objects and is well suited, therefore, for use on spatial networks to identify connectivity priorities. So just to give you a feel for what a landscape network might look like, the bottom map shows some examples of our previous work. And these are corridors that traverse the highest biomass forests between existing protected areas. So high biomass corridors are shown in white, and they're connecting protected areas in gray. And then the background layer shows satellite-derived biomass estimates. So the goal of this work was to identify areas that simultaneously contribute to forest connectivity and carbon sequestration. So we'd like to build on this work by increasing the detail of the analysis to 30 meters, focusing more on biodiversity with the inclusion of forest integrity, providing quantitative estimates of the importance of a given patch or corridor for overall landscape connectivity, and of course working in close consultation with countries when developing these data layers. And so just to wrap up, looking at the charts in the upper right portion of the slide, for a given pixel, for a given patch, or even an entire landscape, by the end of the project, we want to have a tool that can be used to assess the current state of fragmentation and connectivity, as well as how it is trending over time. So we want to be able to answer questions like, is fragmentation increasing or decreasing around high integrity forest patches? Is connectivity between nearby patches increasing or decreasing over time? And what effect might further forest loss or forest restoration have on connectivity? So we can see the current state is represented by the yellow dots. And we know that a given forest landscape can move depending on what happens with land use change. But ideally, with conservation and management, we'd like to push areas towards higher integrity, lower fragmentation, and higher connectivity. So that is, I think I'll finish with that.
Great, Patrick. And Oscar, would you mind next on the next slide talking about the species occurrence analyses?
Yeah, this is Oscar here. So as has been explained in the previous slides, this project is going to be producing entirely new data sets on forest integrity, as well as connectivity and landscape pattern. So a really important question for us is, well, are these new data sets a good measure of the condition of forest biodiversity? So not only the condition of the forest and the integrity of the forest, but also the biodiversity within. So to answer this question, we are planning to use population trends and range maps for approximately 1,000 IUCN listed mammal species. What we'll do is determine if trends in forest integrity, connectivity, and landscape pattern, which we've mapped, within each species range is able to explain the population trends of the species. If we find that changes in forest integrity, connectivity, and landscape pattern do explain species trends over time, this analysis will give us the evidence base for using our new maps in national plans to conserve biodiversity, ecosystem services, and attain the SDGs. That's all I have, so we can go to the next slide.
Thanks, Oscar. And although Jamie pointed out how many countries don't have access to spatial data layers, the countries that have had many spatial data layers often find that it's very difficult to interpret these massive amounts of data. And so converting data into knowledge that helps guide management is a considerable challenge. In this regard, we're planning to take an approach as described in this slide to try to interpret trends in the data relative to basically the health of the vital sign or the ecological integrity metric of interest. This is just an example from my home area of the greater Yellowstone ecosystem in Montana and Wyoming, showing change in number of days below freezing, so a measure of coldness, and how that's been decreased, over the model period from 1950 to 2099, with the period of record in black, and then the others, the future periods in various colors for different climate scenarios. And the notion is that to interpret those types of trends, that we would basically be looking at, has there been a 10% decrease in the relevant metric, a 20% decrease, or a 10 or 20% gain, and use that to identify whether there's deterioration or stability, or whether an improving situation. Again, that if a resource was found to likely be improving, that might lead to one set of management conclusions. If it's stable, another set, and deteriorating, another set. Now, our period of record will be from 2000 to about 2017, so much shorter than this, but still we'll be assessing trends within that time period. And then, Jamie, if we could go to the next slide. We're very much interested, as I've said, in collaborators really being able to access the results of the project and use them. And that's a key interest of the NASA Applied Sciences program. So this term decision support, you may or may not be familiar with it, but it refers to providing computer-based tools by which people can access data, analyze it for their location, download it, convert it into tables and graphics for reporting. And these will be capabilities of this UN Pulse Lab decision support system that'll build upon the Mangala spatial planning tool that Jamie described at the beginning of the project. And the hope is that you'll actually be able to interface this with a tablet or an iPhone, and so that it'll be highly usable among collaborators that have various accesses to technology. And then if we could go to the final slide, Jamie, the project was developed in the realization that there's now really many global efforts to develop spatial data layers and to make them available. And Jamie described some of those with the Nature Conservancy and and others. I know many of you are working within GeoBond, an international program that has identified so-called essential biodiversity variables, and those are listed here. And there's a very large international effort to develop those. So highlighted in green are just two of those that our project will contribute to. And then GeoBond as well is developing decision support tools. And we hope to work very closely with different GeoBond groups to be developing tools in common, so that ultimately the larger system that Jamie described would be taking full advantage of the GeoBond data layers along with those developed in this project. And that GeoBond would be able to take advantage of the layers that we're developing in this project. And so with that, Jamie, and Christine, that concludes what we had in mind for the science presentation. Thanks everybody for your patience in getting through that.
Great, thank you so much, Andy, Scott, Oscar, and Patrick for that very informative presentation. We're now at the top of the hour, but I hope that we can all stay on for 15 minutes of question and answer, which I'll facilitate. And then I understand if anyone needs to leave, they could just go ahead and do that. We are recording this session and we're also taking notes, and we will share that in English and Spanish by Monday. Okay, so the next question comes from Tong, and it's, have you found any difference between the NASA data or the data that's being developed through this project and the national level data sets? And in that case, how will we manage that situation? It's a big question. I'll take a start at it and then turn it over to the rest of the group. So I think the idea is that this project is developing new data layers that are not yet available in the public domain. So they're data that no one would have yet at the national level. However, we recognize that the various ministries are developing data at different points, and Indonesia is a country that has a lot of data. Colombia is a country that has a lot of data, and so in those cases, your project workflow or outcomes might look different in a country that doesn't have as much data. And so my suggestion is that we would manage that during the work planning process. And I actually jumped in and forgot I had a slide myself on timeline, but for the sake of time, I'll just go ahead and share that the next steps would be, we want you to digest this information, continue to ask lots of questions with me about if this is the right project for you, and then we hope that we can secure a formal commitment from the pilot countries by the middle of July. Once we have commitment, we would begin working with each country, also as we're working together to develop the 6NR timeline to figure out how this project fits into what you're looking to do. And I think that would be the time where we're really figuring out how these data layers fit in with what you're doing at the national level. Does anyone else want to add anything to that response?
Yeah, if I could, this is Andy again. You know, we're very, very interested in collaborating with you within your countries to best understand what data layers are currently available and how our project may be able to provide new information to you. So, for example, Matt Hansen's layers on canopy cover, for example, have been available through Global Forest Watch, and it may be that some countries have been accessing that, and hence that would be one of the foundational layers that we're using here. And so we very much hope to meet one-on-one with whatever collaborators are interested in really going over the current usage of data, discussing what we might be able to provide in addition, and evaluating really how to make this project most useful to each country. So we hope to have that type of synergy with you.
I think there's one other perspective. Let's take protected area database that WCMC manages. If your country has a more robust data set, then we envision that you could use your own data as a different layer and analyze that with your own data. So we truly envision a sandbox environment to which you can either take data and graft it onto your own national systems, or you can take your own national data systems, data sets, and add it to this system to get the answers that you need in order to plan, act, and report on some of the key questions related to Aichi targets and the SDGs. Chrissy, back over to you.
Thank you, Jamie and Andy. The next question is, will you share the presentation with us? Absolutely. We'll share the presentations, the recordings, and also the notes in Spanish and English by Monday. The next question is, what is the role for us in this project? Do we have to provide information, or will we work together to develop the analysis of each country? And that question is from Jessa, and I'm going to unmute her, Jamie, while you go ahead and take a lead at answering the question.
Okay, and who's the question from?
This is from Jessa.
Okay, great. Hi, Jessa. It really is up to each country to decide how you'd like to engage. If you would like, for example, to have a hands-on role in determining which of the trends are being analyzed, we'd welcome that. Our job, we see, is providing a minimum set of information. And if countries want to take a more active role and go further or deeper, we'd really welcome that. Maybe one of the things I can point out is that we know in COP14 in Egypt, there will be a lot of interest around spatial planning, spatial data. And we've selected your countries because we see you as potential leaders in this debate and leading the way in how using data to transform our NBSAPs and national reports will help better drive action toward 2020 and beyond. So it's really up to you. Maybe I turn it over to you if you have further questions.
Jessica, you're unmuted. Jessica, you're unmuted if you have anything else to add. There, okay. Sounds like we've answered the question then. So the next question is, this is a very interesting project, but very difficult to do in a short period, especially for Indonesia. Based on the experience, how long is it predicted to finish for a big country for the many islands of Indonesia?
I think this is a question for Andy.
I agree. Andy, over to you.
Yeah. Well, it's a very good question, and undoubtedly there'll be some some realities and some hurdles that provide very large challenges. But in general, I think the answer would be that's the beauty of remote sensing, that we basically have this detailed data, in the case of the forest data, 30-meter cells for the globe on this annual basis. And so actually processing those data for Indonesia has been done. Matt Hansen's been doing analyses in particular for Indonesia. And so at least relative to the forest layers and then the human footprint, that's at a kilometer scale. We have those data in hand. We'll be updating them, but in general, we'll be able to analyze data for those areas within the time frame of the project. Now, for other data layers, the time may be too short, and for probably the level of analysis that people may may ultimately want to do, they won't be completed in the course of the project. But with the tool set that's developed, those analyses can continue and the data sets can be updated well into the future. And so the hope is that this is a system that will continue to be in place for many years, allowing ongoing analyses.
Great, thank you, Andy. Okay, I'm not seeing any more questions in the box or hands raised. We do have a few more minutes. If somebody has another question, please just raise your hand or type your question in the box. Oh, actually, we have a lot more questions. Okay. This is from Michael. How, if at all, is ground truthing of the data considered in the project? For example, forest cover data needs verification in the field.
Andy, this is for you too.
Well, maybe Scott or Patrick or Oscar would want to respond.
And while you're formulating your answer, the next question is quite similar. The question is, the project will only use publicly available data to be incorporated in the spatial data analysis, or will the researchers do validation on the submitted data and collect ground data at the site level as well? So two very similar questions. Over to you.
Hi, this is Oscar with the Human Footprint. Just with respect to the human footprint and the validation, what we've done for our recent update and what we'll do for this project as well is to use high resolution imagery, so about 30 centimeters to 50 centimeters, and we've developed a visual interpretation scorecard for interpreting cumulative pressures on the ground in these high resolution images. So what we have is about 3,001 kilometer sample plots around the world where we do this visual validation using the high resolution imagery and scoring, and then we compare that to the human footprint. So that's a mechanism. It's not getting out in the field and measuring directly, but this very high resolution imagery actually gives you a very clear idea of what's there on the ground in terms of pressures on forests. So that's, in terms of the human footprint, that's how we do our validation. And I'll hand over to anybody else if they have comments on the forest condition Landsat data.
Yeah, this is Scott. Matt Hansen's group does something quite similar. Basically, visual interpretation by a large number of students as part of his group as a validation effort for the forest change. Forest height is a little bit of a different situation, and I think it's something that would be really useful to have data from various countries to provide that kind of information where available. I'm part of another project, as is Patrick, for a new LiDAR system that's going onto the space station. And as part of that project, we'll have field effort from a number of different participants contributing. So we could probably do something similar here in terms of incorporating data sets that others may have.
And
Right.
This is Patrick. For the connectivity side of things, so connectivity is certainly very difficult to validate, and that too is a case where we ideally work with countries to identify areas from national level data sets or more local level data sets that are known to be important corridors, and so that's something that we'll just continuously work on. And there are larger kind of international biodiversity corridors that have already been established. And so there's a certain amount of data that we can draw on in an attempt to validate some of the connectivity metrics and corridors that we map with this project.
Any further questions?
Yes, sorry, I was on mute talking. There's a comment that ties into this I'll just bring up. And it's saying that due to experience, there's experience mapping biodiversity loss based on the specimen data collection. It's difficult to find georeference data because most of the data is only mentioned the local name. So it sounds like we're getting a lot of questions and feedback about how to incorporate local knowledge into the project. And then the last question is actually, is there any need for ground truthing the data? I think we've addressed that, but I turn it back over to you for closing remarks.
Could I respond to this issue of local knowledge, local data?
Absolutely, Jamie.
One of the features that we really want to incorporate into this system is that anybody can overlay additional data. So if national practitioners know, for example, where species have been lost, where species data occur, if there is even a workshop where people can have shape files and overlay the system, we want this to be a system that merges national data, local understanding, and global data sets to provide the best information available to countries. And maybe if there are no other questions, I see we're at the time. Chrissy, shall we go ahead and wrap up?
Yes, absolutely. I just wanted to thank everyone for their time and encourage you to continue to dialogue with me with questions that you have after you digest the information that's been shared in this webinar. Again, we're looking for formal commitment by the middle of July. So we look forward to hearing from you. We'll send out the notes, the presentation, the recording early next week. And I just want to give a hearty thanks to all of our presenters today and to everyone that came on, and thank you for your patience, both with trying to host a webinar in Spanish and English the first time and for the technical issues that we had. So thank you so much, and we look forward to hearing from you.
Thanks so much, Christine and Jamie. Really an excellent session. Thanks. Bye.
Yes, thank you all.